If you search interface versus abstract class in Java, right now, most of the top results will tell you something like this. At first glance, this looks correct. This is what most developers learn, what many interview answers still say, but this answer is outdated. And not just slightly outdated, fundamentally outdated. Look at this line carefully. This answer was correct before Java 8. Once Java 8 released, this answer is completely outdated. And here is the real problem. If you give this answer in a modern interview, a senior interviewer will immediately know your understanding stopped at Java 7. So what changed? Why is this answer no longer correct? Because Java evolved. So Java 8 introduced something called default methods and static methods in interfaces. Java 9 added private methods in interfaces. And these changes completely blurred the line between interface and abstract class. Interfaces are no longer just contracts. They can now contain behavior, share logic, even hide internal implementation. So in this video, I am not going to give you the old answer. I will give you the modern correct answer. What actually changed after Java 8? What differences still matter today? When to use interface versus abstract class in real systems? And how frameworks like Spring actually use both. By the end of this, you won't just answer this in an interview, you will understand how Java is designed. Before Java 8, an interface was extremely simple. If you look at old Java, an interface could only contain two things. One is abstract methods, one is constant. That's it. Every method you wrote had no body. Every class implementing it had to write the implementation. So interface was purely a contract. Now watch what Java 8 changed. Now look at this interface carefully. Don't read everything, just follow step by step. First, look at this. This is the old world. No body. Implementing class must implement it. Now move your focus here. This is new. This method has a body. And here is the key point. Classes implementing this interface get this method automatically. They don't have to write anything. They can override it, but they don't have to. So this is the moment where interface changed forever. Interface is no longer just a contract. It can also provide behavior. Now the question is, why did Java introduce this? The old way became a headache for developers working on massive libraries. If you wanted to add a new method to an interface, you would break every single class in the world that implemented that interface, because they would not have an implementation for the new method. Let's take a real example. So the Java team had millions of implementations of list. Now they wanted to add new method like for each stream. So if they added abstract methods, every existing implementation would break. That's not acceptable. So they introduced default methods, add new behavior without breaking existing code. That's the real reason. Now look at this part. This is also new. Static method inside interface. So this method belongs to the interface itself, not to objects, not to implementations. So now interface can do three things: define contract, provide default implementations, provide utility methods. Now Java 9 took this even further. Look at this carefully. Focus here. Where is this method coming from? Now here is the important part. This method is private, which means implementing classes cannot see it, cannot call it, cannot override it. This method exists only to support default methods. It's internal logic. Because when you're writing multiple default methods and having common logic, without repeating that common logic, we can place it in a private method and we can use here. So now interface can reuse code internally without exposing it. Before Java 9, you had to duplicate logic across default methods. Now you can centralize it. If you look at modern Java, interface is no longer just what to do. It is now contract, behavior, internal logic. And because of this, the difference between interface and abstract class is no longer obvious. So now the real question becomes, what is the actually difference? Let's break that. Now that you have seen what Java 8 and Java 9 introduced, let's answer the real question, what is actually different today? When you look at this table, don't try to memorize everything. That's the mistake most developers make. Instead, let me simplify this for you. Focus only on what truly matters. First, look at these two rows, concrete methods, static methods. Both interface and abstract class support them now. So the old statement, interface has no implementation, is no longer true. Now look at private methods. Java 9 provided that. Abstract class, default, it is yes. Now look at inheritance. Interface, multiple inheritance is possible. Abstract class, only single. This is still important. A class can implement many interfaces but can extend only one class. Now forget everything else. There are only two differences that truly matter today. The first difference is instance state. Look at this row. Interface cannot have instance variables. That means no per object data, no mutable state. It will have only constants. We already seen, right? So whenever you declare any fields, let's say int x equal to 10, that by default it is public static final. Now when you compare with abstract class can have fields, can hold state. Every object has its own state. Every object has its own data. So if your design needs state, interface cannot help you. Now look at constructor. Interface will not have any constructor because interface is never instantiated. Abstract class will have constructor. And this is very powerful because constructor runs when subclass is created. Every subclass automatically gets this behavior. Now combine these two, state plus constructor. This is what abstract class gives you and interface cannot. Everything else has mostly converged. Both can have methods, have implementations, have static logic, have private helpers. But only abstract class can hold state, control object creation. So instead of remembering 10 differences, just remember this. Interface is behavior, abstract class behavior plus state. That's the modern understanding. So the real question is, when should you use which? Because knowing difference is not enough, you need a decision rule. Let's see that next. Now that we understand the differences, let's answer the most important question. When should you use interface? When should you use abstract class? I'll give you a simple rule. If you understand this, you can answer 95% of real world classes. Use an interface when you are defining what something can do. Use an abstract class when you are defining what something is. Now don't just memorize that, let's understand it properly. We'll see the real examples. Now look at these two interfaces, exportable and auditable. These are not types, they are capabilities. Now look at this subclass. This subclass is implementing exportable and auditable. Focus on meaning what we discussed previously. Order is not exportable. Order is not auditable. But it can do export and it can do audit. So that's the key difference. Interface defines capabilities. That's why multiple inheritance works here. You can mix behaviors freely. That's Now look at this abstract class. We have discussed abstract class is identity plus shared state. Now look here, this is not capability. This is identity. Base entity is something real, something that holds data. Look at these fields. Every subclass get this automatically without writing any code. Now look at this constructor. This runs for every subclass. It guarantees state is initialized. You cannot do this with interface. Now look at this method. Focus on the keyword final. This means subclasses cannot change this flow, but they must implement the details. So the structure is fixed, but details are flexible. So that's the powerful design here. Now look at the subclass here. Subclass which is extending the base entity. Now every user will have ID and created it. Follows same describe logic without any duplication. So now bring it together. If your problem is what can this class do, use interface. If your problem is what is this class, use abstract class. Now, so again, interface is capability, abstract class is identity plus shared data. Now you understand the modern difference, but this is still not enough for real systems. In the next video, I will show you how Spring actually uses this and the mistakes most developers make in production. Thanks for watching GK TechVerse. Subscribe and keep upgrading your skills. See you in the next video.